Hello everyone. I am preparing this video to introduce a new feature with FlashX, which is the containerization capability. And I was asked to make this tutorial so that it is easier for others to understand what I've been doing. So here we go. Okay, so why containerization? Containerization has a lot of advantages in terms of reproducibility. I faced challenges in my own research, and um, that has led me to conclude that containerization can actually be more scalable in terms of scientific research. So that's one big aspect of it. Second is continuous integration and continuous deployment pipeline for testing FlashX software or any other software. Containers are very useful for that. And of course, another aspect that I've been exploring recently is using machine learning workflows and other Python libraries for data analysis with codes like FlashX, which use Fortran C interface. So that's a good that's really helpful that they offer these kind of abstract away these kind of complexities for different tasks. But they also have different challenges, and the biggest one that has been at the forefront for the longest time has been security, because containers provide root access, and therefore they are less secure for high performance computing platforms. But this issue has been addressed with the development of Singularity container service. So there are a lot of container service out there. The most popular one is Docker for cloud computing. And then you have Singularity, which was specifically designed for high performance computing systems. So security has been addressed by Singularity. But the other aspect is complexity, because different container services have different interface, and it's just hard to keep all the different options and switches that make the container work more organized. And this is something that I've been trying to address with the wrapper that I've written, which is Maple, that has been now integrated with FlashX and other HPC projects as well. So complexity is the aspect trying to address that. And then the third challenge is performance. And this is an exciting research opportunity because it could really give us more insight on how containers perform with Singularity. Now that Singularity is being installed on a lot of different clusters, we can actually study and test how applications like FlashX actually work with this container service. Okay. So before jumping into, before I don't want to, I really want to take this opportunity to demonstrate how they work. So let me just quickly take you to the command line. I have provided all the instructions in the README of FlashX to install Maple. And let me just show you what Maple is. So Maple is a command line utility and a Python utility. So there is a Python API to this as well, which I'll show you in a little bit. Actually, I can show you right now. So if you go to FlashX tests, um, one of the tests, you can see that I import Maple as a Python API. So there is a Python API interface, and I'll give a little bit of background, a little bit of introduction on that as well. And then there is command line interface, which you can see here, right? So the command line interface is designed to be very intuitive, and it's an evolving design. So if you, let's say, end up using Maple and you face some issues, anything, this is an in-house design, so you can reach out to me and I can, fix it for you. Um, so so the first options that you have is the backend option. So now this option is not necessary. technically you can define this backend in a maple file. So if you look at flashx root directory, you see that there is a maple file, and the maple file defines container name, right? So this is the name of the local container. So maple is designed to be very designed maple, or I want to say the maple command line interface is designed based on a directory structure. So every directory that has a maple file becomes a container, right? So you just define the name of the container using the maple file, and you define the target directory inside the container. So you're saying that you want to mount this working directory where the maple file exists, with following path, with the path mentioned in target, inside the container. And then you specify the backend Docker, right? So if you specify this backend here, you don't need to provide option in the command line interface, because then Maple will read the backend and just apply the backend to all the functionality. And both the backends are mutually exclusive. And the reason that I provided two different backends is because with Docker, it is really easy, more convenient to build containers in comparison to Singularity. So you can technically use Docker to build containers, and then you can convert those containers into Singularity containers to deploy on HPC systems. So that's useful because Docker is more interactive in container design. Okay, so different commands, right? So the different commands, of course, there are like top level commands for login. So like login into your container backend, so you can download your images which are hosted on different repositories online. So Docker Hub, that is Singularity Hub, where images are hosted. There are pull, push commands to pull an image, push an image, and um, there is a scan command to check your images for security, right? And these are more generic system commands. I don't want to focus too much time on these. I want to show you how the meat or the more useful things are located in two separate subcommands, which is image and container, right? So if you type maple image, right, it will list various commands under image, right? So you can build an image, you can delete an image. This command lists all the image in your on your system right now for that particular backend. And then you have squash, which helps reduce size of an image. So if you, let's say if you are working with an image and you introduce too many layers, and I understand that some of these technical terms may come as jargons, but bear with me. This is just an introduction, and I'm happy to talk to you about the details of all the commands if you want to. Um, and I'll just show you, I'll show a demo, but I'm just gonna give a brief overview of the commands. And then tag is, you can tag an image, right? Um, okay, so that's image management. Let's do container management, right? So if you type maple container, you see different commands for container management, right? Okay, so how would you use it within Flash? So after you have followed all the steps that are in the README and installed Maple on your system, you can start uh, as simply as just typing maple image build, right? You provide the name of your local image. Let's say you want to name your local image Flash image, right? That's what I want to name it. It's FlashX image. And I want to build this image from a remote repository that is hosted on Docker Hub, right? So if you, so you can say, so you type, this is my username, and then from Flash, and that's the repository name. I want to pull the latest, right? So now you're building the local image first, right? So you get all the local image. And this step takes a lot of time because this is the most expensive step, because you're downloading, um, I want to say 2.5 GB of content from the image on your local machine. So ideally, once you build an image, you don't have to delete it from your system, right? Okay. So this step is similar to a git clone, I want to say, right? Okay, so you have built your image and you can check it. So if you type maple image list, you can see that this is the FlashX image that was on the remote repository, which is here on your local machine. And this is the local image that you have built using FlashX. Now, the reason that you want to do build is because FlashX has root access. So you won't be able to use it because Maple is designed to be secure. So you can only uh, let's say use a container if you have non-root access. So that's why when you build the image, you are building it as a local user. So now your user privileges are transferred to the image. So that way you avoid the whole root security issue. Okay, so now that we have an image, right, and we have defined our container in this maple file, right, what we can do is we can do maple container or and you can supply the name of the image, which is the FlashX image, right? So you can see that there is some command that is executed, and you can check maple container list to see that you have created a FlashX container, right? Using a FlashX image, right? Now let's say you want shell access inside this container. So you can do maple container shell, and now you're inside and you can see that you have files. Your working directory has been mounted inside the container, and if you, let's say, look at the privileges are user privileges. So let's say you create a file in here, let's say touch test.md, and you see that it is being created using uh, your user signature, right? So if you log out of the container, right, so you can just do exit, um, you can see that your user privileges, which is my local user Akash, has been transferred to this file. So you can easily remove it, whatever you want to do, right? So you can run everything inside the container, which has the Flash developer environment, and you can develop your code, and then you have all the changes retained with your user privilege. Okay. Um, you can see that once you exit out of the shell, you can also log in. So you can do maple container shell, right? And you are back in, right? If you want to stop this session, you have to do maple container rinse, and it will close the FlashX container, right? So it will read the container from the maple file in here, and it will rinse and stop the container. Okay. All right. So let's say remove this file. Okay. Oh, I see. Okay. I built this object directory using a root access, so that's why it's not allowing me to delete it. So I'll have to use a sudo command. All right. Okay. So let's say you want to now build a simulation. Okay. So how would you do it? So you will do, let's pour the container again. So maple container pour image equal to flashx image, right? And you have started a container, and then you can go into maple shell, maple container shell, and now you're inside. So let's set up a simulation. So in README, let's set up one of the simulations in the README that I put up, which is this one. All right. Okay. Right. So you can execute normal flash like a regular flash command, and the site will be home site. The site path will be home site, which is path inside the container. So if you actually go to the home, you'll see that there is a site here. And then there is the mount directory where FlashX is, right? Okay. So let's go back, set up incompressible flow. And this time the object directory is created with user privileges. So earlier, now if I exit, I can delete it um, from my local machine. Okay, so I go inside object, I compile the flash simulation. Actually, let me use more processors. All right, perfect. Let's say now I can copy the simulation to, because this is the mount directory. So once you um, uh, close this container, the flashx root directory will disappear from the container, right? So you want to save your executable before that happens. So you can just do, so you can go to home, let's say, and you can make a directory, right? Let's say I want to, uh, okay, I think we have to log in as root because you cannot make a directory like this. All right, but this is a good segue into um, the root privilege. So this is why I say, like, when you use Docker, it's easier to build images because you get these type of issues. So let's do maple container rinse and remove the object. And let's execute another maple image build command, right? So I want to do maple image build, flashx root image, right? Or I can just do flashx root, and then I want to build it from flashx latest, right? So now this is build, oh, sorry. I built it again as a user. So let me just, so if you do maple image list, let me do maple image delete flashx root, and it deletes the image. And then I want to execute the same command, maple image build. But I want to supply the flag as root. So when I do that, it builds image as the root user. All right, so I built a build image as a root, and then now I can pour the container. So I can do maple container pour image flashx root maple container shell, um, and then I can compile a simulation. Let's do lid driven cavity. So that I can demonstrate it in a different example later on. Lid-driven cavity. Okay, so now you see that all of this is the user privilege, but the object directory is root privilege, right? That doesn't matter. We are just going to compile the simulation and then delete this directory from the container, right? So let's say make J5. Simulation is compiled. Okay. Now we can go to the home directory and create a run directory, right? And copy this mount flashx object flashx to run. Okay. All right. So if you look at the run directory, the flashx executable is here. All right. Okay. Now you can exit out of the container, and before you rinse the container now, before you stop it, so you can see that the container is still running, right? You want to make sure that you commit these changes, because now you want to have this flash executable inside the container, so that then you can build it on a HPC machine using Singularity, and then run it, right? So what you want to do is maple container commit. You're committing to the container, and then you supply the image name, and you want to say the image name is let's say I want to commit it back to FlashX lid cap, right? So I want to create a new image and commit it there. All right, so if you look at image list, right, you have um, the lid driven cavity image. All right. Um, so I think I was an issue with my screen recording, so there will be a little break, but that's okay. So last time, so before my screen froze, I showed you how you can commit the image, right? So you get inside the container, you make the changes, you commit the image, and then you can just simply push. So you can do maple container, oh sorry, maple push, and you can do this image, right? And then you can say the remote registry name. So let's say I wanna push it to a new image, Akash Dhruv, FlashX, lid driven cavity. All right. Push. I'm not gonna do this right now because I already created an image this way. But if you execute this command, you will be able to push the image. Um, but like, let's say now you have pushed the image and now you want to run this on an HPC platform on a machine, right? How would you do that? All right, so let's look at that aspect, right? Okay, so I have this other repository called workflows. It is under FlashX. So if you do git remote get URL origin, you will see that it is located in the FlashX organization. I've created this directory because I want to use it for integrating machine learning applications with FlashX. Or machine learning workflows with FlashX. So, and I'm going to be using quite a bit of containers there. So, just so I can just show you how to use it on a cluster in that repository, right? So that this repository structure is organized based on the simulation. So if you go to um, simulation main directory structure, you will see that there is an income flow directory, right? And within that, there are different simulations. So I'm trying to maintain the same structure inside workflows. So if anybody is interested in contributing to this repository, keep that in mind. So you go into that workflow and then you have layer-driven cavity setup, right? And you see that now there is a flash.par, right, which contains the parameters for the simulation. And there is a maple file, which provides the name of the container, right? Um, and then you specify the backend, which is Singularity backend, and then you provide the target that you want to mount it to inside the Singularity container. All right. So what I want to do is first, I want to now build. So since my backend is now Singularity, right? I can simply build an image from the image that I pushed inside the container, or image that I pushed to Docker registry, right? So if you go to Docker Hub here, right, you see I have different repositories for different images. You have FlashX, you have AMRX, other applications that I'm working with. So if you go to FlashX, you will see that there is the latest image and there's this lid-driven cavity image that I pushed before, right? So what I can say is, all right, let's do maple image build. Name of the image, which is lid-driven cavity. Um, and then the name of the remote image. In this case, I have to supply the source because I'm building with Singularity, and Singularity can read images from different formats. So I say that it downloaded from Docker. and then the name of the repository, which is flashx lid-driven cavity, right? So now it's going to start the build process with using Singularity backend. Um, it'll take some time. The build process is most expensive, but once you have the image on your machine, then it works then the rest of the things are faster. But you only need build process to be executed once. So um, yeah, all right. So if you do maple image list, right, you see that you have this lidcav.sif, which is the Singularity image format. That's the extension for it, right? Now, it is important that the OpenMPI inside your container is compatible with OpenMPI on your local cluster or local machine. So I'm just gonna load OpenMPI that I have here on my local machine, which is this. All right, so if I do, if you want to quickly check, I can just do maple container pour from image lidcap, and I can do maple container shell, and I do MPI run version is 4.0.3, and then I exit out of the container and I do my local MPI version, which is 4.1.1. So they are from MPI 4 version, so they should be compatible. So to check if they're compatible, we can just execute MPI run, number of tasks, do maple run, maple container run, image equal to lid driven cavity, and then the command you want to execute inside, right? So what this container is going to do, what is going to happen is maple container run is going to execute a, a command inside the, it's going to first, it's going to use the lid driven cavity image that we just built and execute this command home run flashx inside the container, and it is going to mount this directory. So all the data files will be produced in this directory, right? So I do that, you can see, voila, it works. MPI run, everything is working, and if you see here, you have all these data files that are produced from the container that are here now, right? There are a lot of different things you can do with the containers. This was just an introduction. You can use it in any folder on your machine to organize your simulations, workflows, whatever you want. I am happy to talk about it. If you have further questions, feel free to reach out to me on Slack. Thank you for watching this video. Bye-bye.